In today's video, I'm going to talk about random number generation in Python. So, random number generation is useful in several different aspects of software development. For example, you can use it in simulations of weather forecasting or stock market stock predictions, in which way the prices are going down or up. You can use this feature of random number generation in dice rolls and card shuffling games. You can also use it in testing for generating sample test data. This can also be used in machine learning for the purposes of initialization of certain data or splitting data, which is an essential feature of machine learning and certain algorithms. Furthermore, it can also be used in cryptography to generate secure tokens on the basis of some random seed. And as it is very well said, randomness adds realism and unpredictability to the code. So we need our code to be unpredictable sometimes. So element of chance or unpredictability can be introduced in a Python program using the Python's random module. It supports certain methods, several methods. Random.random is one of them. Random.randint with a couple of parameters. Random.uniform and random.choice, random.choices, and random.sample. And in the next few slides, and then in the Google CoLab demo, we will see what each of these functions do. So, for example, if we want to use any of these three functions, I need to import the random module, at least in the cell in which I am working in Google CoLab. If I invoke an instance of random.random, it will generate a floating point number between 0 and 1. And if I invoke an instance of random.randint, I have to give it a couple of parameters. So it will generate an integer between these two numbers, 1 and 10, for example. And if I put some other numbers here, then the generated random integer will be between those two integers, which I pass as input parameters. And the difference between random.randint and random.uniform is that this works on a uniform probabilistic distribution, and it will generate a float and between the numbers which are passed as parameters. So here is a sample output. For example, if I invoke this, I will get this in output, and if I invoke this, the second one, I will get this output, and if I invoke the last one, I will get this output. Now, as far as the functions of random.choice and random.choices and random.sample are concerned, these work on lists, tuples, and sets. For example, if I have this list and I invoke the method random.choice, so it will create for me one randomly selected fruit from this list of fruits which I passed it as a parameter. And for random.choices, I need to provide this k, and k basically tells how many elements are to be retrieved randomly from the list which I am passing to this choices method. So this one will allow the duplicates. And the last one is random.sample, and fruits, again I am passing the list and I am passing the k. Here, and the difference between the choices and the sample method is that in the sample method, it does not select values from the same key of the list again. So it is possible that, for example, here 0, 1, and 2, 3, 4, 5, and 6. If it selects the value at index or key 2, which is cherry, it is not going to select this value again at this index. But it is possible that it selects the value at 6. So in the results, you might see duplicate values, but the keys or the indices will not be repeated again, which is possible in the random.choices. So when you're working with the random numbers, it is often desired to debug programs involving random numbers. So for that, we often need to provide a seed to the random method. And once we give a seed, then the sequence of random number generated is the same depending upon that seed. That is why these are called pseudo random numbers, because they are not true random numbers. And in most practical situations which we do with the computer programs, these pseudo random numbers actually work quite well, and we really don't have to resort to the true random numbers, which actually is quite hard to implement by means of computer programs. So if, for example, we don't give any seed in this case, then it will be working on the basis of system clock or system entropy, and on the basis of that, it will generate a random sequence of a number or generate a random number as desired, as required. So in that case, it will also depend upon the operating system which is being used. And if, for example, that is not even known, it makes of the os.u random method to generate a specific number of bytes for which, on the basis of which a seed is generated, and on the basis of that particular seed, the random numbers will be, or one random number or a sequence of random numbers can be generated. So we can also make use of the random function or the random method to shuffle certain data. For example, if I have a deck of cards which I'm trying to create by means of this range function, which will generate numbers from 1 to 52, and those are being stored in as a list in the variable cards, I can invoke the random.shuffle method to shuffle the elements of this list which is in the cards, and then I want to see the first 5 cards or the first 5 elements of the cards. So these were some methods provided by the random module, and if we want to work more the larger data or large scale simulation, then we can make use of the NumPy library. I will have a separate video on NumPy, but for the purpose of random number generation, we can make use of the methods provided by this. It is basically a fast array based random number generation. It supports different distributions, normal and binomial, etc. It provides the following functions: np.random.rand, np.random.rand integer or int, and np.random.randn, which is random number generation over a normal distribution. And then np.random.choice. So how do these work? So for example, if I give I try to invoke the instance np.random.rand and pass some value 5, it will make use of a uniform probabilistic distribution of between 0 and 1 and generate a number out of that. And in the same way, if I invoke the randn method of np.random, it works on normal distribution, and keeping in view that it will be generating a sequence of numbers which, for example, fulfills for mean equal to 0 and standard deviation equal to 1. And if I invoke the np.random.randint method, and I need to give parameters from which number to start and from which at which number to end, and I also need to specify how many integer choices or how many random numbers are to be generated, and that many numbers will be generated. So to summarize, we make use of random module for small scripts, and if we have a large number of data elements, then we can make use of random NumPy.random for scientific, and it is also used for scientific computing. So we also need to make use of seeds sometimes for reproducibility, and we also need to know the difference between choices and the sample. And we should avoid random for security purposes, and instead we should use the secrets module instead for invoking or enhancing the security in our applications. So NumPy makes basically generating large arrays of random values fast and easy. So that was it for today, and now we can switch to the Google CoLab demo. So now we are in the demo. So I have actually written some code to quickly run through these examples. The first one is I need to import the random module or the random library, and I have made use of the random function, the randint function, and the uniform random.uniform function. The first one will generate a float value between 0 and 1, and the second rand.integer will generate an integer between 1 and 10, and the last one will generate a float value between 1 and 5. So let's run this. So here you see the first one is generating a random number for between 0 and 1. The second one picks a number between 1 and 10 randomly, and the last one picks a random number, floating point number between 1 and 5 randomly. If I rerun this, you will see, most probably you can see different values. So this is the phenomena of random number generation at work in Python. And then we studied a few more methods: the choice method, the choices method, and the sample method. If I run the first one, it will provide me a randomly chosen fruit from this list fruits, and the second one will provide me 2 fruits. The third one will also provide me 2 fruits, but in the second one, duplicate key values are possible, and in the last one, duplicate key values are not possible. Let's run this, and here you see that we see pineapple and banana at the second in response to the second call, and banana and apple. And if I try to run this a few more times, you see banana picked randomly, pineapple, cherry, orange, banana, and then date, banana, banana, cherry, and orange, apple, and banana, pineapple. So that's how it works. Now if we want to provide some seed, so we can just invoke here. I have not given any seed. It is possible that I gave some seed, for example 4, and then I rerun this. When I give a seed, you will see the same random number generated each time. But if I remove, for example, the seed, now in this case it will be invoking the os.urandom method, which is working on the basis of bytes on the system entropy. In that case, return due to the system entropy, and it depends on the operating system also, and it also depends on the system time. So it is generating numbers, random numbers, which are again on the basis of some seed, but though that seed is not really known to us explicitly. So now we see this time it is going to generate different numbers, because now it is reading on the basis of system entropy. For example, if I give the seed 7 and run it a few times, it is generating the same number, because now it is on the basis of the seed 7, and that's why it's a pseudo random number. It's not a true random number. If we know the seed, we can replicate the production or the generation of these random numbers. Then is about shuffling of cards, for example, and I make use of the range function, which will generate values from 1 to 52, and I store them in the form of a list in the variable cards, and then I invoke the random modules shuffle method. And for example, if I want to see what is inside card, I can see here. After shuffling, I also want to see what is inside card, whether it changes or not, or whether the shuffling has worked or not. And then finally, I want to see the first 5 elements. Now I press Control Enter, and here you see first it generates values from 1 to 52, then it shuffles, and then it prints the first 5 values from the shuffled cards. If I rerun this, now again you can see that shuffling has changed the contents of the second list, which is the shuffled card number, and the first 5 numbers have also changed again. And now you can see that the shuffling has resulted in rearranging the values in the deck of cards, or the value of card which we generated by the range function. Likewise, you can also make use of NumPy. We can invoke the random.rand method, which works on the uniform distribution, and for the normal distribution you have to invoke the method randn. And finally, if you want to have some choices, randint, then you have to provide these 2 parameters, any number like 2, 5, 1, 10, and you also have to specify the size or the number of elements you want to generate randomly. If I run this, here you see that for the uniform distribution, it is generating values, 5 values between the range 0 and 1. And for the second one, it is generating values having a mean 0 and standard deviation of 1. And it is generating again 5 values because of the parameter I passed here. And the last one, it is generating 5 values between 1 and 10. If I rerun this, then you might see slightly different values. So that was all for today's demo. Thank you very much. And in the next video, I will be covering some other interesting topic about Python programming. Thank you very much.